Welcome to Topic 5, Unit 1, Polar Coordinates and Equations. You should have seen from the Desmos investigation that polar coordinates use r and theta to describe a point, where r is the radius and theta is the angle in standard position. Example 1, plot the points with the following polar coordinates, a, 3, and 5 pi over 3. So I'm going to start by showing an angle in standard position. 5 pi over 3 is in quadrant 4, and my radius is 1, 2, 3 units, and there's my point. Part B, 2 and negative pi over 4. Negative pi over 4 is in quadrant 4, and my radius is 1, 2 units. Part C, I'm graphing the point with a radius of 3 and a theta of 0. So the positive x-axis is where theta is equal to 0, and I will go out 1, 2, 3 units. So this is the point 3, 0. And part D, negative 2 and pi over 4. Well, I'll start by drawing the terminal side of my angle. Pi over 4 is in quadrant 1. Now, if I were to go 2 units on quadrant 1, that would be a positive radius. If I'm going to have a negative radius, I have to go exactly 180 degrees opposite, and I'll go down 2 units in the negative direction, and there's my point, negative 2 and pi over 4. Example 2, plot the point P with coordinates 3 pi over 6 and find other polar coordinates r theta of this same point which meet the following conditions. So we'll start by graphing the point 3 pi over 6. So pi over 6 is the small angle in quadrant 1, and I'll go 1, 2, 3 units. Now for part A, we want to have a positive radius, but theta has to be between 2 pi and 4 pi. Well, we know that if I were to add a full rotation, I could get an angle that's between 2 pi and 4 pi that still represents the terminal side. So I'm going to take my pi over 6, and I'm going to add 2 pi, which is 12 pi over 6, and I am going to get a theta that's equal to 13 pi over 6. So now I'll describe this point as 3 and 13 pi over 6. For part B, we want to have a negative radius, and theta needs to be between 0 and 2 pi. So if I want to describe this point right here using a negative radius, that means I have to have an angle that is 180 degrees opposite. So if I were to add pi to pi over 6, then I could use a negative 3 for my radius. So I'll take pi over 6 and I'll add pi, or 6 pi over 6, and I get 7 pi over 6, which is between 0 and 2 pi, and I will describe this point as negative 3 and 7 pi over 6. Part C, we're back to a positive radius, but now we want to have a negative theta that's between negative 2 pi and 0. So remember that we started with the point 3 and pi over 6, and if I were to subtract a full rotation, or 2 pi from pi over 6, I'm going to get negative 11 pi over 6. So I'll describe this point as 3 and negative 11 pi over 6. Now we can convert from polar coordinates to rectangular coordinates, because when you look at a triangle that we could make with our r and our theta and our x and our y, we can see that x has to equal r cosine theta and y has to equal r sine of theta. Example 3, find the rectangular coordinates of the points with the following polar coordinates. So x is going to equal 6 of cosine of pi over 6, and y is going to be 6 times the sine of pi over 6. Well, the cosine of pi over 6 is the square root of 3 over 2. So this means that x is equal to 3 times the square root of 3, and y is going to be equal to 6 times the sine of pi over 6, which is equal to 1/2, and 6 times 1/2 is 3. So the rectangular coordinates for this point are 3, root 3, and 3. Part B, we have negative 4 and negative pi over 4, so x is going to equal negative 4 times the cosine of negative pi over 4, and y is going to be equal to negative 4 times the sine of negative pi over 4. Well, cosine is positive in quadrant 4, where negative pi over 4 is, so this is going to be root 2 over 2, which simplifies to negative 2 times the square root of 2. And sine is negative in quadrant 4, so this becomes negative 4 times negative root 2 over 2, which is going to give us a positive 2 root 2. So this ordered pair in rectangular coordinates is negative 2 root 2, 2 root 2. So it's very formulaic to convert from polar coordinates to rectangular coordinates, but it's slightly more complicated to go from rectangular to polar. So we have some steps. Step 1, plot the point xy and note the quadrant the point lies in. Step 2, determine the distance r from the origin using Pythagorean theorem. Step 3, determine theta. It's kind of easy to see with quadrant 1 because if this is y and this is x, then theta is going to be equal to the inverse tangent of y over x. In quadrant 4, it works out the same way. It's just going to be the inverse tangent of y over x because remember, inverse tangent only answers with angles in quadrants 1 and quadrant 4. So if you know from your sketch that theta belongs in quadrant 2 or quadrant 3, let's look here at quadrant 2. If I were going to do the inverse tangent of y over x, my calculator is going to give me an angle down here in quadrant 3. And then because I know the period of tangent is pi, I'm going to add pi to get my answer in the correct quadrant. This is also going to happen if the angle is supposed to be in quadrant 3, because the inverse tangent of a positive number is going to give me an angle in quadrant 1, and then I'll have to add pi to get my angle into quadrant 3 where it belongs. Example 4, convert 0, 3 to polar coordinates. So first, you always start with a plot. So the point 0, 3 is right here. Now I can tell from my picture that theta is equal to 90 degrees or pi over 2. And also because my r is a vertical line, I can see without even calculating that r is equal to 3. So I can now say that my r and theta are 3 and pi over 2. Example 5, we're going to convert negative 2 to polar coordinates. So we'll start with a sketch. 2 and negative 2 puts my angle down here in quadrant 4. I can calculate my r by using Pythagorean theorem. So that's going to be equal to 2 squared plus negative 2 squared, or the square root of 4 plus 4, which is the square root of 8, which simplifies to 2 root 2. And maybe I can just see what that angle is, but if we want to use the formula, we would say theta is equal to the inverse tangent of y over x, or negative 2 over 2. So this is the inverse tangent of negative 1, and we know that this answer is negative pi over 4. So this point is 2 root 2 and negative pi over 4. Example 6, we're going to convert negative 1, negative root 3 to polar coordinates. So as always, we start with a plot. And here is negative 1, and here is negative root 3. So here is my terminal side. My r is going to be the square root of negative 1 squared plus the square root of 3 squared, which is the square root of 1 plus 3, or the square root of 4, which is equal to 2. My angle, though, is in quadrant 3. So I can say that theta is equal to the inverse tangent of negative root 3 over negative 1, or the inverse tangent of the square root of 3. Well, inverse tangent of a positive number is going to give me an answer in quadrant 1. The inverse tangent of the square root of 3 is the angle pi over 3. But we know from our picture that we have to be 180 degrees or pi opposite, so I'm going to add 3 pi over 3, and my theta is going to be 4 pi over 3. So my polar coordinates are going to be 2 and 4 pi over 3. So we're going to shift gears a little bit now, and we're going to talk about polar equations. In example 7, it says transform the equation r equals 6 cosine theta from polar to rectangular form. Now remember, we only have so many ways available to relate x and y and r and theta. We know x equals r cosine theta, y equals r sine theta. We also know that x squared plus y squared is equal to r squared, and we know that theta is equal to the inverse tangent of y over x. And that's all we have. So let's look at r6 cosine theta. If we want to convert it to rectangular form, we have got to eliminate r and theta and only have x and y in our answer. So if this was r squared instead of r, I'd be able to replace r squared with x squared plus y squared. One of the ways I can turn the left side into r squared is to multiply both sides by r. So now I've got r squared equals 6r cosine of theta. Now I can substitute in x squared plus y squared for r squared, and I can substitute in x in place of r cosine theta. So now I have got x squared plus y squared is equal to 6x. Now theoretically we could be done, but this doesn't really look like a familiar equation. So let's just see what happens if I were to manipulate this equation a little bit. So this is the same as x squared minus 6x plus y squared is equal to 0. If I were to complete the square, x squared minus 6x plus 9 would complete the square, plus y squared is equal to 9. I have to add 9 to both sides. And then in factored form, I'm going to get x minus 3 squared plus y squared is equal to 9. And that is the equation of a circle centered at 3, 0 with a radius of 3. Example 8, transform the equation 4xy equals 9 from rectangular to polar form. Well, this one is a little bit easier because I can just substitute in r cosine theta and r sine theta for x and y. So this becomes 4 times r cosine theta, r sine theta is equal to 9. With a little creative manipulation, I can say that this is the same as 2r squared times 2 sine theta cosine theta is equal to 9. And you might remember the identity that 2 sine theta cosine theta is actually equal to sine 2 theta. So this is the same as 2r squared sine 2 theta is equal to 9. I just need to remind you though, with example 7 and example 8, as soon as you eliminate x and y or r and theta, depending on which direction you're going to, you can be done. So this could have been our final answer for example 7, and this could have been our final answer for example 8. That's all for now. Thanks for watching.